Derivatives of hyperbolic functions. The analogy with the hyperbolic functions can be updated with the differentiations formula for the trigonometric functions, but beware that the signs are different in some cases. Listing of the formulas and proofs with derivatives of hyperbolic functions. You check it, the trigonometric functions and the hyperbolic functions are their different signs, because sine x is given with the hyperbolic sine h can be added here. This is the derivative of here. d over dx sine hx must be cos hx, and the derivative of the cosecant hx must be minus cosecant hx must be tan hx, and the derivative of the tan hx must be secant h square x. On the second here, on the derivative of the cos hx must be sine hx. On the derivative of secant hx must be minus secant hx must be cotangent hx. And the cotangent hx must be minus cosecant h square x. We see about the inverse of hyperbolic functions. Both sine h and tan h are one-to-one functions, but because they have inverse functions, which is denoted by sine h inverse and tan h inverse, but cos h is not one-to-one, because when we restrict it to the domain 0 up to positive infinity, it becomes one-to-one function, like this. And the inverse of hyperbolic functions here, y it must be sine h inverse x, and the y cos h inverse x, and the y must be tan h inverse x. Now we have to substitute the following with the sign without to make out by using the hyperbolic function. The inverse function converts to the hyperbolic function. It becomes sine hy, which is equal to x, cos hy, which is equal to x, tan hy, which is equal to x. Then we put in the hyperbolic functions by using with the main functions. Let's go to the practical examples on inverse of hyperbolic functions. Show that cos h inverse x must be ln x plus root of x square minus 1. We can substitute the following by using the hyperbolic functions to reverse like that. Particularly, it's similar with here. Sine h inverse x must be ln x plus root of x square plus 1. It must be the x's element for all real numbers. And the cos h inverse x must be ln x plus root of x square minus 1 must be x greater than or equal to 1. And the tan h inverse x must be 1 over 2 ln 1 plus x minus 1 minus x must be minus 1 less than or equal to x less than or equal to 1. We have a particular formulation of the equation by using the inverse of hyperbolic function. First, let's identify cos h inverse x. Reverse to the hyperbolic function, we can determine it. Cos h y must be e the power of y plus e the power of minus y over 2. Then make it a crisscross here with the 2x, which is equal to e the power of y plus e the power of minus y. Reverse the sign here. E the power of y minus 2x plus e the power of minus y, which is equal to 0. Both must be multiplied by ey. E the power of 2y minus 2x the power of ey plus 1, which is equal to 0. What do you think about the e the power of 2y here? We check it. There is the square r here. We factorize out it's become the quadratic equation. It's become used by quadratic formula. E the power of y must be 2x plus or minus root of 4x square minus 4 over 2. X plus or minus root of x square minus 1. Then, the last answer will become y, which equals to lam x plus root of x squared minus 1. This is all about applied mathematics lesson 9.